Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra II 2.5 notes. So today we're looking at correlations and best fitting lines. So we're going to take some data and we're going to find a line that best goes through this data, and then we're going to write an equation for that line. So this data might not be perfectly linear, so the points might not make a perfect line, but they're kind of going to approximate a line for us so we can throw a line in there. All right, so here we're looking at how do I write an equation for a best fit line is my essential question. All right, so the best fit line is the best line that fits all data. So it's got the same amount of points above and below. So that's kind of the thing for the best fitting line that we're going to talk about in a little bit. All right, so a correlation, and you see a lot of this in statistics and things when you get in some upper level math classes, is that correlation is how well a line can approximate a set of data. All right, so there's kind of three types of correlations that we're gonna be focused with here: positive, negative, and no correlation. Okay, so a positive correlation is when this line that you approximate it with has a positive slope in a set of data. So that's if I have some set of data that would look like this. So here's a bunch of different data points, and as you guys can see here, this straight line right there has the same amount of points above and below. So that's why that one is a positive slope, that line has a positive slope, and so on. All right, so now as we keep going on here, for negative correlation, you guys got it, it's the same exact thing, but it's a line that has a negative slope. All right, so this guy has some points, let's say in here. This has a negative slope. All right, and the last one, relatively no correlation, would be when you say, hey, the data cannot be approximated with a straight line. All right, so that's if the data looks something like, hey, it's all over the place. It's not necessarily in a straight line really anywhere. There's points kind of all over. So a line can't really approximate it. All right, so here we go, moving on to kind of the example that we're looking at here. We're going to actually write an equation for the best fit line. So today I'm going to give you some data, and then you kind of have to go through and you have to put in a straight line that has the same amount of points above and below that line. And then once you find that line, then we're going to find 2 points on that line to help us write an equation for it, like we did in section 2.4. All right, so we got really good at that in section 2.4. So this really section isn't a whole lot new. Okay, so I just took the time here before and I graphed all these points. You guys can take a second and go through graph through 5, 3, 5, 2, 7, 1, 3, all these guys, right? But now I'm going to go through and actually draw this best fit line, okay? And there should be the same amount of points above and below. So I'm going to kind of go through here and draw this best fit line. Yours might be different than mine. So that's the thing about these, is your answer might be a little bit different than mine, which is okay. So I'm going to kind of start from here. I'm going to it's easier for me to draw a line like this, and then I'm going to go just like that and call that my best fit line. So it doesn't have to be perfect, the same amount of points above and below. It doesn't have to be exactly perfect, like I said. It should be in the ballpark though. Okay, so now I look and I have to pick 2 points. So find 2 points that are on your line that can identify the XY. These points do not need to be data points that you plotted. So as I look here, I see this point right here. That kind of goes through that nice little point right there perfectly. I'm going to pick that point, and then I'm also going to put this one right here, and that one actually was a piece of data that we actually plotted. Doesn't have to be, sometimes it might be. Okay, so now here's our points. We have this point, which is -3, -3, and then I'm going to use this point, which is 1, 3. All right, so those are my points. I have -3, -3. I'm just going to write those up here, and then I have 1, 3. Okay, and all I have to do is now use these 2 points, and I have to find my M and my B. All right, and that's what we did in section 2.4. So now at this point, this should be nothing different. I'm going to find my slope. I'm going to use my Y's and then my X's. So I have 3 minus a -3 all over 1 minus a -3. All right, so as I look, both of these turn into all positives. So I have 3 plus 3 is 6, 1 plus 3 is 4, so this slope is going to be positive 3 halves is my m. All right, so now I have this. I have y equals mx plus b. I still have to solve for my b. I still got to find out what that is. That's my question mark still. So now my y, you can pick either one of these points. I'm going to use 1, 3 because that's kind of a little bit easier. It's positive and there's no negatives in there and they're kind of smaller numbers. So I'm going to use my y is 3 is equal to my m is 3 halves, my x is 1, and then I have plus b. All right, so that's why we have this pretty nice here, is that now I can take 3 halves times 1 is 3 halves plus b. And here's the thing, is that when in like section 2.4 is when I gave you problems to work on, I gave you nice numbers, so they actually came out to be pretty good numbers, right? But now when you're picking your own numbers and your own points on these graphs, you might get some ugly numbers, and that's okay. Fractions are okay. We know how to deal with those. We've talked about those in the beginning of this year. But you might get some ugly numbers because now I have to subtract 3 halves. I have to subtract 3 halves. So now I know that my b is equal to 3 over 1 minus 3 over 2. All right, now I need a common denominator, so I got to multiply this by 2, multiply this by 2, so now I have 6 over 2 minus 3 over 2, which is 3 over 2. That's my b. So notice here that my y-intercept is also 3 over 2. So my answer here is y equals 3 over 2, because that's my slope, x, plus 3 over 2. And you have to kind of ask yourself, does this make sense? Does it make sense that I have a y-intercept of 3 over 2, which is like right there? I would say it's in the ballpark. It's not exactly, because my line's not exactly perfectly straight. But now does it make a sense that I have a slope of 3 over 2? So I go up 1, 2, 3, and over 2, 1, 2. I would say so, absolutely. So now this makes sense. You can ask yourself, does my answer make sense? All right, so again, you might not end up with really great numbers. They might be a little ugly, but I know you can deal with those fractions. I know you guys have showed me that. So please come find me if you have any questions, and thank you for listening.